this do? It will represent the complex periodic signal using simpler simpler signals. And these simpler, which kind of simpler signals? That is sinusoidal. Sinusoid means what? It is a combination of sine cos, right? So we assume to produce an approximation of the original signal, and the approximation becomes more accurate as more terms are used. So that we can represent in the form of cos nx and sin nx. Nx means what? Number of sinusoid that you are using, or harmonic that you are using. So once we talk about the Fourier series, so Fourier series of a function fx, Fourier series of a function fx in the interval minus pi to pi. As I mentioned earlier, the period is 2 pi under certain condition. Under certain conditions, that is the trigonometric series. Trigonometric series. So that you know, the trigonometric series is fx can be written as a0 by 2 plus summation n is equals to 1 to infinity an cos nx plus bn sin nx. If we could write in such a way, and also the a0, an and bn, these are said what? These are constants and known as Fourier coefficients. Okay, so basically what we do, we have the function fx and we represent it in the form of trigonometric series, or we can say the harmonic form, sinusoidal form that we can say. So what are the conditions to apply the Fourier series, to select the Fourier series? This is known as Dirichlet condition. So what is Dirichlet condition? That we can see here. A periodic function, suppose we are talking about any function fx, is said to satisfy Dirichlet condition if it is single valued and finite in any period. Second condition is it has at most a finite number of discontinuities within a period. So period that we have defined earlier, minus pi to plus pi. So it is 2 pi, that is the length will be. And it has a finite number of maxima and minima. Maxima and minima in any one period. So these are the conditions to apply the Fourier series. So I hope so the term is clear.
Yes, sir.
Okay, So now, so it can be observed all the periodic functions found in engineering application that can be expressed as a Fourier series. Now, after defining the Fourier series, the convergence theorem. It states that if a function f(x) satisfies the Dirichlet condition, so that you know, so these conditions are given here in the interval minus pi to plus pi, then its corresponding Fourier series converges to f(x) at any point that say, let's say x, which belongs to minus pi to plus pi, where f(x) is a continuous and converges to that I can write, where f(x) is continuous and converges to what we can write here, converges to 1/2 f of x minus 0 plus f of x plus 0. So left and right that we have taken as an average at a point x that belongs to minus pi to plus pi. So f(x) has ordinary discontinuity as well that can be defined. So if there is any type of discontinuity, so we can use such formula as well. Okay. Now the thing is, find the coefficients of Fourier series, that is a0, a1, whatever that we knows. So to find this, we required some formula as well before to get the Fourier coefficient a0, al, like that. So what do you understand by Fourier series now?
तो डिरिचलेट कंडीशन से उससे
कोई भी फंक्शन हमें दिया गया है f(x), right? That can be written in the form of sinusoidal function. Sinusoidal means what? a0/2 summation n is equals to 1 to infinity an a cos n x we can write plus bn sin nx. If we could write in such a way f(x), that will represent the Fourier series of the given function. Before finding this coefficient, that we required a0, a1, an and bn. So ultimately, when you are converting any function in the form of Fourier series, you required to calculate a0, an and bn. So before this, some formula we need to remember. Some formula that I can write here. Suppose we are talking to c to c plus 2 pi. So the period that you can see the 2 pi sine nx dx. What will be the value? It is going to be 0, where n is what? An integer. So where I use n, it is an integer. Second formula, c2 again, c plus 2 pi that I could write, and it is what? Cos nx dx. This is also going to be 0. So this formula you must remember. c2 c plus 2 pi, so it will be minus pi to plus pi. Now the next formula is cos mx into cos nx dx. So it is also 0 if m is not equals to n, where m and n are integers. Next formula we have integration again from c to c plus 2 pi. It is sin mx into sin nx dx. It is also again 0 and the same condition holds if m is not equals to n. A condition that you can take if m is equals to n and m and n are integer. So in that case, if you take c to c plus 2 pi cos mx cos nx, that will be cos square nx dx. So it will be equals to pi. Next formula, c to c plus 2 pi is the limit given. If we talk about sin square nx dx, then it will be also what? The pi. If m is equals to n, so that I could write here the formula. Again, integration from c to 2 pi sin mx cos nx dx. So it is equals to what? It is 1 by 2 c to c plus 2 pi, and it is going to be sin squared 2nx dx. So as you know, it is going to be what? 0. So this formula you must remember. You must remember before getting the value of a0, a1 and an. Okay, so you must remember sin nx, cos nx, cos m and nx all are 0. Sin m, sin n all are 0. If m is equals to n, then cos square nx is pi, sin square nx is pi, and this is going to be 0. So first we go for the finding what? A0. So what we can write here, the Fourier coefficient to write a0 an. First we write here given in the Fourier form that we can write a0 by 2 plus summation n is equals to 1 to infinity an cos nx plus bn sin nx. So our objective is to determine these coefficients a0, a1, a2, or b0, b1, b2 like that. So first we do here integrate both sides between minus pi to plus pi. So if we integrate in such a way, so what we get integration of fx dx minus pi to plus pi. Here you can get 1 by 2 integration of okay, a0 that we can write a0 by 2 dx. A0 right now we have to take here, so one that I'm considering minus pi to plus pi plus. It is going to be integration from minus pi to plus pi summation n is equals to 1 to infinity an cos nx plus bn sin nx, and it is going to be this dx. Up to this level, any question?
No, sir.
Okay. So this value is going to be what? Minus infinity, minus pi to plus pi. If you are integrating, a0 is constant that we can take outside. So it is going to be a0 by 2 pi to pi. It is going to be 2 pi, right? And this will be how we could write this. It is going to be summation minus pi to plus pi integration. Sorry. N is equals to 1 to infinity minus pi to plus pi an cos nx dx plus summation n is equals to 1 to infinity from minus pi to plus pi bn sin nx dx. Is it so? Can we write this like that?
Yes, sir.
Okay. So if we are writing, so you can go to the formula that given in the last slide. So minus pi to plus pi sin nx, it is 0. Minus pi to plus pi cos nx is also 0. If you put c is equals to minus pi, right? So in that case, this term and this term is going to be 0. So what we get, and this 2 and 2 will be cancelled. So finally, what we get here, a0 is equals to 1 upon pi integration from minus pi to plus pi fx dx. See, in some book, in the place of a0, it is written a0. In that case, what happens? A0 is equals to 1 upon 2 pi. Okay. In that case, it will be what? 1 upon 2 pi, that we must understand. So according to book, it differ. Chaliye. Now we can move to the next an. So for that, what we do here, again you have written fx is equals to a0 by 2 plus summation n is equals to 1 to infinity an cos nx. Again I write plus summation n is equals to 1 to infinity bl sin x. So what we do here now, since we require to find what an, and if you go to the formula cos square nx dx integration, that is going to be pi. So what we do here, we multiply both sides by what? Cos nx and integrate it between minus pi to plus pi. So what we get, this side you get integration of fx cos nx dx from minus pi to plus pi. This will equals to integration a0 by 2 that you can take outside. So it is cos nx dx from minus pi to plus pi. So this is going to be 0 plus integration minus pi to plus pi summation an cos nx into cos nx infinity, and this one is the what? Minus pi to plus pi summation n is equals to 1 to infinity bn sin nx into cos nx dx. Okay, so what we get, this is going to be 0, no issue. So it is minus
Yes.
pi to plus pi fx cos nx dx, that is equals to a 0. This is going to be 0, and it is going to be summation n is equals to 1 to infinity integration minus pi to plus pi an cos square nx dx plus summation n is equals to 1 to infinity bn, that I could write outside, minus infinity to plus infinity sine nx into cos nx dx. So this is also going to be 0. This is also going to be what? Equals to 0. Okay. If we could write mn different, then what will happen? If we could write mn different, so what we can do, in the place of cos nx, we could write cos mx. So it is not going to change the result right now, but it will be true for all mn. Okay, so I am putting here m. So what we see, this is again, it is going to be 0. So what we get, minus pi to plus pi fx cos mx dx. This is going to be equals to, so what we can write here, it will be equals to 1 by 2. Okay, this would not be cos square, it will be cos mx into cos nx dx. So in such case, what we do, 1 by 2 if we take, and it will be minus infinity to plus infinity. So 2 times of cos mx cos nx. So what we can write this, it will be cos m minus nx plus cos m plus nx. Is it so? Can we
Yes,
write
sir.
this? It equals to dx. So in such a way, again we use the previous logic here. So cos mx and into cos nx we are talking about. So you can check the formula again. So if both are equal, m and n are equal, then it is pi. If it is different, then it is going to be 0. So in such a case, if we do this, these two are equal, m and n both are equal, so it is going to be cos 0 is 1. And if it is different, so its integration is going to be what? Integration is going to be 0. So ultimately what we get here, it is going to, okay, an left here, an. So it is an by 2 integration minus pi to plus pi cos m minus n x dx is equals to minus pi to plus pi fx cos mx dx. I have written in the revert way. Okay, so what we get here, an is equals to, okay, this is going to be what? This is going to be pi.
Yes, pi
This
hoga,
is going
sir.
to be pi, right? And 2 times that we can take here. So an is what? An is 1 upon pi, and 2 upon pi that we can write, minus pi to plus pi fx cos nx dx for n greater than is equals to 1 that we can write. So again, in some book it is 1 upon pi, it is some book it is 2 upon pi. So depend on the question. Right, so it should be 1 upon pi. If we do directly here, m and n is equals to 0 naught, so that we can do here. So an is 1 upon pi minus pi to pi integration fx cos nx dx. That is your formula. In such a way, you can get the bn also. So now you know the reverse first sign that we can do. A0 by 2 plus summation n is equals to 1 to infinity an cos nx plus summation n is equals to 1 to infinity bn sin nx. So what we do again in this one, we multiply both sides by sin mx and integrate by integrate between minus pi to plus pi. We get what we get here again, integration minus pi to plus pi fx sin nx dx. It is a0 by 2 integration minus pi to plus pi sin nx dx. That is going to be 0 again, and directly I could write here the an integration minus pi to plus pi sin, okay, sin mx, no, sin mx into cos nx dx plus bn minus infinity to plus infinity sin nx into sin mx dx. So again, what we see, this term is going to be 0, whether it is m and n are different or the same. So finally, directly I could write bn will be what? What I can write about the bn?
क्या बोलते हैं, a naught by 2 integration minus pi to pi sin nx dx minus
Bn is going
an.
to be 1 upon pi minus pi to plus pi. This one fx sin nx dx, because this when m and m is equals to n,
ये तो हाँ,
you know, then we get this one. So bn is this one, an is 1 upon pi integration from minus pi to plus pi fx cos nx dx, and a0 is what? 2 upon pi subject to condition. You are taking a0 by 2 or only a minus pi to plus pi fx dx. Right?
Yes, sir.
So this is the way to get the all the values a0, an, and bn. So it is not only applicable for minus pi to plus pi. You can do for 0 to 2 pi as well, because the period is 2 pi that we have calculated. So any question which is given, suppose find a Fourier series of the function. So fx you must remember, and accordingly a0, an, bn that you require to calculate. So let us take one example to get the Fourier series of the function. So example one that we can take, find the Fourier series for find the Fourier series for the function fx is equals to e to the power minus ax. where x lie between minus pi to plus pi. Also prove that pi upon sine hyperbolic, let me check the question. It is 2 1 upon 2 square plus 1 plus 1 upon 3 square plus 1 plus 1 upon 4 square plus 1 and so on. So this is the question. To solve this question, what we required first to find the Fourier series. So we have given here fx is e to the power minus ax, right? And we know how to write the Fourier series. Fx will be a0 by 2 plus summation an cos nx plus bn sin nx. Our purpose here to get all the Fourier coefficients. To get this, first we write a0. A0 is what? 2 upon pi from minus pi to plus pi fx dx. Always write the formula first. So what we get? It is 2 upon pi integration minus pi to plus pi. Fx is given e to the power minus ax dx. So it is see a0 by 2 now, then it is 1 by pi. And it is 1 by pi. If a0 then 2 by pi. So it is going to be 1 upon pi e to the power minus ax upon minus a minus pi to plus pi. So what we get? E to the power a pi minus e to the power minus a pi divided by a pi. So this is your what? This is your a0. So 1 by pi, no? So it is a0 by 2. So what we can write this? This is going to be equals to sine hyperbolic a pi upon a pi. This we got it here. Sine hyperbolic a pi upon a pi that we get. Okay, this is a0. Wait, this is a0. If we go for here, a0 by 2, because this term is a0 by 2. So this is going to be 2 into this. Then it will be sine hyperbolic a pi by a pi. Now, an is what? 1 upon pi integration from minus pi to plus pi fx cos nx dx, right?
Yes, sir.
So it is going to be 1 upon pi minus pi to plus pi fx is e to the power minus ax cos nx dx. So how we can write this integration? So 1 upon pi is okay. It is e to the power minus ax upon a square plus n square minus a cos nx plus n sin nx minus pi to plus pi. I have used direct integration, but you can do this. Okay, so after putting the limit, what we get once you put the value of pi here, so it will be 1 upon pi e to the power
minus a pi
minus a pi upon a square plus n square minus a cos n pi plus n sine n pi minus 1 upon pi e to the power
a
pi upon a square plus n square. Okay, if you put here minus, so it will remain minus.
ये तो माइनस ही रहेगा,
So
तो वो cos n pi ही हो जाएगा ना सर?
cos n pi.
हाँ, प्लस
Okay,
अब ये माइनस n sin pi
minus n sin n pi. Okay, what is the value of sin n pi?
सर n pi की वैल्यू तो ओके sin n pi 0 हो जाएगा ना?
Sin n pi is 0. Okay, so we can write this. Okay, what is the value of cos n pi?
अब वो -1 और 1 के बीच में फ्लक्चुएट करता है सर.
So can I write here? It is going to be a upon pi. See, -1 plus 1, it will fluctuate, right? So minus minus plus is here. Here it is minus, right? So it can be written as a upon pi and a square plus n square e to the power minus a pi minus e to the power minus a pi, and it is going to be cos n pi. Is it so?
सर ये cos n pi की टर्म्स कट नहीं हो जाएगी?
क्यों कटेगी? ये e to the power minus a pi is there, ना? That we keep the value 1. That we keep the value cos n pi and cos n pi, that will be 1 there. So what we could write here, 1 minute. Either we could write cos n pi, or we should write here -1 to the power n. So ultimately e to the power minus a pi minus e to the power plus a pi by 2. So it is going to be -1 to the power n 2 times of a. It will be sine hyperbolic a pi upon it will be pi a square plus n square. Is it so?
Yes, sir.
So by having such value, we get the value of a. Now our next task is to get the value what bn. To get bn again, so what we do? Now I could write directly. Bn is equals to what? 1 upon pi minus pi 2 plus pi fx sine nx dx. So it is going to be 1 upon pi minus pi 2 plus pi e to the power minus ax sine nx dx. So this can be written in the form of, it is 1 upon pi e to the power minus ax upon again a square plus n square minus a sine n pi minus n cos n pi nx minus pi 2 plus pi. So once we put the limit, what we get, it will be 1 upon pi is the common e to the power minus a pi plus pi that we are putting here. So a square plus n square minus a sine n pi minus n cos n pi. And here, once we put the minus sign, so it is minus e to the power minus minus plus a pi upon a square plus n square, and it will be a sine n pi, because minus minus it will be plus, minus n cos n pi that we get. So again, sine n pi is 0. So what we get here, okay, cos n pi is there, so n will be the common term. So I could write the directly, it will be again cos n pi, that I can write minus 1 to the power n, and it will be 2n upon a square plus n square, but pi should be here, and it will be sine hyperbolic a pi. So this will be what your Bn.
Yes, sir.
So finally, the Fourier series of fx. Therefore, the Fourier series of given fx is equals to e to the power minus what we have given, e to the power minus ax, is given as, so formula now I'm not writing here, fx is e to the power minus ax, that will be a0 was sine hyperbolic a pi upon a pi plus summation n is equals to 1 to infinity, so an is what, minus 1 to the power n की जगह in place of n that we can write 2a sine hyperbolic a pi upon pi a square plus n square cos nx plus summation n is equals to 1 to infinity minus 1 to the power n 2n sine hyperbolic a pi upon pi a square plus n square. So what we can see, either you can write a cos nx and n sine nx also there. So whatever you have common, that you can take common, and that can be written in such a way also. Okay, so second part, 2 minutes that I will take. Now put here x is equals to 0. So by putting x is equals to 0, what we get, e to the power 0, that is going to be 1 sine hyperbolic a pi upon a pi, that will be remain. Okay, x is equals to 0 and a is not also in the series, so x is equals to 0 and a is equals to 1. So it will be what, sine pi only upon pi, sine pi upon pi plus what we can write, summation n is equals to 1 to infinity. So what we could write here, minus 1 to the power n sine hyperbolic a pi. So it is going to be what, sine hyperbolic pi only, and 2 also that you could write upon a square plus n square, so that we can write pi into 1 plus n square, that we have taken common in the both. And here what you left, cos nx, x is 0, so it is going to be cos 0 plus sine 0. So ultimately you get here what you get, minus 1 to the power n 2. Okay, sine hyperbolic pi is the common, so this side you can take 1 upon sine hyperbolic pi It is common in these two terms, right?
Yes.
And 2 is also that you can take common here 2, and pi is the above. So it will be equals to, so it here you can write 1 by 2 plus. What we left, cos 0 is 1, sin 0 0, sin hyperbolic pi upon pi, that you have taken this side. So what we left, minus 1 to the power n upon 1 plus n square only. Summation minus 1 to the power n upon n square plus 1 only left. So it is going to be 1 by 2 minus 1 by 2 if you put n is equals to 1. Right? Put n is equals to 2, so it is plus 1 upon 2 square plus 1. Put n is equals to 3, so it is going to be minus 1 upon 3 square plus 1. Plus 1 upon 4 square plus 1, and so on, that you can get. Okay, so that you can get in such a way. So this is your final correct answer.
Acha, sir.
So in the question, we need to correct it here. The odd term should be the minus, right?
Yes.
The odd term should be the minus. So sometimes question may be different. So here 2 we have taken the 2 pi upon this one. So 1 by 2 will be cancelled. 1 by 2
सारे terms तो रहेंगे.
And 2 that you can here, this 2 you can take this side, so that your answer, it is given the common 2. In the solution we have taken here, so that can be interchanged. So in this way we get the Fourier series, and we can interpret for the point as well.